Welcome to The Explainer. Today, we're tackling a topic that is absolutely critical, yet honestly so often misunderstood in electrical engineering and facility management. We're talking about the selection logic of busway plug-in units. Basically, how to get that perfect fit. Now, a lot of folks think this is just, a simple parts order. But actually, the precision here literally dictates the safety and stability of your entire power system. So, are you ready? Let's uncover the engineering truth behind getting that perfect fit.
Okay, let's dive into this because we need to address what is arguably the most dangerous assumption in the entire industry. When you're ordering or designing, is simply telling a supplier, hey, we need a 100-amp bus plug, really enough? The answer is a massive, resounding no. Relying solely on amperage to place an order is a total trap. This kind of incomplete information, it directly leads to incredibly expensive project delays, and worst of all, it plants deadly safety hazards right on the job site.
Take a look at this comparison we've got here. On the left, you see the industry myth. It's this idea of treating a bus plug like a universal accessory, kind of like a standard power strip you just plug into your living room wall. But on the right side, well, that's the rigid engineering reality, series-specific geometry. Look, just because a brand new plug looks, close in size to the busway opening, absolutely does not mean it's compliant. It has to be rigorously tested and specifically designed for that exact series of busway. In our world of electrical engineering, close enough is downright dangerous.
So here's our roadmap for today's explainer. First, we'll look at rejecting the universal plug misconceptions. Second, the 3 core types of selection logic. Third, the 6-point compatibility checklist. Fourth, how to say goodbye to invalid RFQs. And finally, installation, inspection, and compliance standards. Let's jump right in.
Part 1. Reject universal. Let's look at those plug misconceptions.
Now, what's really interesting about this is how it highlights the truly unique design of every single brand and series. Look at these 4 core physical elements. You've got frame geometry, the stab arrangement inside, the external latch design, and the safety interlocks. You literally cannot ignore these specific physical elements. They have to match the busway flawlessly to ensure secure connection. I mean, you can't just force a square peg into a round hole, right? It's the same here. Electrical connections leave exactly 0 room for error.
Moving on to Part 2. Selection logic, and the 3 core types you need to know.
The first type we're looking at is the breaker bus plug. You can think of this as the go-to option for most projects. It uses a circuit breaker for overload and short circuit protection. And really, its biggest advantage is that you can quickly and manually reset it right after it trips. Out in the field, this is absolutely perfect for dynamic project environments, places that require frequent maintenance, or maybe where load characteristics might change and you demand a fast restoration of power.
Next up, we have the fusible bus plug. Now, unlike the breaker type, this one relies on traditional fuses. And yeah, while a blown fuse does mean you have to physically get in there and replace it, fusible plugs are the absolute heavyweights for high short-circuit protection. Plus, they often come in at a lower initial cost. If your facility has extreme fault current risks and you need absolute, heavy-duty, single-use blocking protection to shield your core equipment, this is for sure your premier choice.
The third type is the metered bus plug. And in today's data-driven world, this is so much more than just a plug. It provides your basic electrical protection, sure, but it also monitors current, voltage, and energy consumption in real time. For modern data centers or massive commercial complexes that need really precise energy billing, the metered plug isn't just a nice accessory. It's a critical, intelligent node for highly detailed energy management, a real game changer.
Which brings us to Part 3, the 6-element compatibility checklist. Listen, before you place a single order, you absolutely must pass this 6-point compatibility and ratings check. Honestly, consider this the ultimate do-not-skip cheat sheet for any procurement officer or MEP contractor. You need to meticulously verify 6 things: brand and series compatibility, frame geometry, stab arrangement, latch design, interlock mechanisms, and the electrical ratings. Let me be perfectly clear here. Checking off these exact 6 points is literally the only way to guarantee the plug will actually fit during installation and operate safely once it's energized.
Let's move to Part 4, saying goodbye to invalid RFQs. So the crucial point is right here on the screen. Frame geometry, stab arrangement, latch design, and interlocks must be verified before sourcing. Why? Because as we established earlier, 100 amps is never enough information. If your request for quote only lists amperage, you're getting a blind quote. It's really that simple. And this kind of incomplete RFQ, it leads directly to absolute disasters on the job site. We are talking massive installation delays, wildly expensive rework, and severe safety hazards. Just don't do it.
Finally, Part 5, Installation, Inspection, and Compliance Standards. Even if you nail the procurement side, execution in the field is your final line of defense. Here is the mandatory 5-step installation inspection sequence. Step 1. Latch. Ensure the plug is physically secured to the housing. Step 2. Ground. Verify that the ground pins make first contact. This is a non-negotiable life safety baseline. Step 3. Torque. You must use a calibrated torque wrench to verify bolt tightness. Step 4. Interlock. Test it. Make sure operators cannot open the door while the system is energized. And Step 5. Cable support. Ensure the weight of outgoing cables isn't pulling down on those plug connections. This is a highly methodical, mechanical verification process. It leaves zero room for guesswork.
All of this really brings us to why compliance is so absolutely essential, and we can use Xinma as a prime, real-world example here. Xinma manufactures busways and smart cable management systems that adhere to the absolute highest international and local standards. We're talking IEC 61439-6, NEMA VE1, and GB 31251. As you can see, these stringent standards are exactly what allow their equipment to be successfully deployed in true mission-critical environments. Think hyperscale data centers, rail transit systems, and heavy industrial plants. These standards aren't just paperwork, you guys. They're exactly what keeps critical infrastructure running smoothly and safely.
Which leaves us with one final critical thought to wrap up this explainer. I want you to really think about your own current systems for a second. If an inspector walked into your building right now, today, would your facility's bus plugs pass that 6-point compatibility test?